All right, so in reading this question, the first words that should really stand out to you are they're asking for where is it concave up and concave down. So when we're talking about concave up, concave down, we are interested in the second derivative, figuring out where the second derivative is does not exist or 0, and then drawing a number line for the second derivative. Now, of course, to get to the second derivative, we first have to find the first derivative. So we take our first derivative, we get negative 3x squared plus 6x. Now remember, we're after the second derivative, where is that equal to 0? So we take our second derivative and get negative 6x plus 6. And that is what we set equal to 0 or does not exist. And remember, it's all about the second derivative. So once you get the first derivative, you really could care less about it. That was just a derivative that we got on our way to what we really cared about, setting equal to 0, which is our second derivative. So if we solve for x here, again, we have a linear term. So with any time you have x to the first as the highest power, you can just isolate. So we just have negative 6x is equal to negative 6, divide by negative 6, and we get x is equal to 1. So with x is equal to 1, we draw our number line, and now our number line is going to be for f double prime. So we have f double prime as negative 6x plus 6. So we will plug in a number to the left of 1. So maybe let's say we plug in 0. So if I plug in 0, I get negative 6 times 0, so that crosses out, and we get a positive. So that positive for us, because we're looking at the second derivative, I always think about second derivative, you have 2 letters. So concave up, 2 letters, concave down, 2 letters. So this second derivative positive tells us that it is concave up on that interval. All right, now if I plug in a number to the right of 1, let's say I plug in 3, I get negative 6 times 3 plus 6, so that's going to give us negative, and then plus the 6, so we're going to get a negative. Now that negative, because we're plugging into the second derivative, is going to tell us that we are concave down. So our conclusion from this chart is going to be that we are concave up from negative infinity to 1. We're concave down from 1 to infinity. And keep in mind, anytime you're talking about concave up, concave down, or increasing, decreasing, you always put parentheses. Now, we also have what we call a point of inflection, or an inflection point, at 1, because we have a change in concavity and the first derivative is defined. Now, when you think about a point of inflection, a point means we're talking about x comma y. So anytime we have an x comma y, we will have to plug into the original function. So I will take my original function and I will plug in 1. So I'll have negative 1 to the third plus 3 times 1 squared minus 2. And so when I simplify that out, I just get 0. But again, anytime you're talking about a point, you need to plug it into the original. So here is our conclusion: concave up, concave down, and then our respective point of inflection.